All right, now we need to start talking about states of matter and the different states of matter. I know in eighth grade you talked about states of matter. You've talked about it in biology and the different classes that you've had. But when we start looking at these, some things they need to know about the solids is a solid holds its shape and it has a fixed volume. Um, the molecules are compacted together and holding on to their neighbor so that they don't spread out. When you look at a liquid, on the other hand, a liquid tends to spread out, filling the bottom of the whole container that it's in. And then we move on to gases, which, if we look at the gas, all the molecules will fill the full volume of the container. For example, in the classroom, all the molecules will fill the whole container. In the case of flooding, what will happen is the water will run across the floor, filling whatever space it has to move, where a solid's going to stay in place. When we move to different states of matter, what we have these changes from one state to another. And so typical ones that you guys know about are if we go from a liquid to a solid, then we're going to actually freeze. Okay. Um, if if we're moving from a solid into a liquid, we have melting or fusion. Moving up to going from liquid to a gas, it vaporizes or vaporization. And then from a gas back to a liquid is condensation. Okay, the ones that are probably new for you are moving from a solid into a gas, which is sublimation. Even though the days might be really cold around here for the winter time, you'll notice if we have a really cold spell and we've had snow lay on the ground for a while, the snow seems to dissipate over time. Well, that's actually caused partially because of this sublimation. Some of the water molecules actually are vibrating on the surface and actually sublime into gaseous form. They never achieve the liquid form. Uh, Another place where this happens is typically dry ice. Dry ice will start as a solid. At normal room pressure, it will move right into a gaseous form. Now, going the opposite direction is taking a gas and bringing it back down into a solid. That's called deposition. We also look at this disorder of a system. If you remember, we just finished thermodynamics, and we're looking at this thing called delta S. That's the entropy. And so what we're doing is, as we move from a solid to a liquid to a gas, we're having an increase. So the entropy as we move up is always going to be positive. We get more disorder. Now, a heating curve, so when we start looking at these things, we have to consider a few different things as we go from a solid to liquid to gas. What we have over here on the side on the Y scale is temperature in Celsius. And if we think about water in this particular case, down here at the bottom, we're moving up and it's in a solid form, and solid forms can warm up. One of the things that we look at is if it's snowy outside and it's minus 40, the snow is actually at minus 40. And so as it warms up, when we hit this particular point, well, that's going to be 0 degrees Celsius. What we're going to do is we're going to start to melt at that point. Now, when that starts to melt, it is not going to increase in temperature until all of the ice or all of the snow is actually in a liquid state. Once we become liquid again, we can start increasing and climbing up this ladder until we reach, if we're dealing with water in this case, 100 degrees Celsius if we're at sea level. Okay, and at 100 degrees Celsius, this water starts to boil. And again, the water will not start heating up until it's in gaseous form. Once it's in gaseous form, you'll notice we're going to increase in temperature again. Um, so this particular area, when we're moving up, we actually have kinetic energy going on. There's a little bit of kinetic energy. There's movement of molecules. Here we're changing the potential energy of the system. So those molecules are getting separated, kind of breaking apart and separating out. Again, here's a point of potential energy, and again up here we are in kinetic energy. And so anytime we have an increase in temperature, we have an increase in kinetic energy. Moving on to a cooling curve is slightly different. And what happens is it kind of does one of these too, where it steps down, but it's got this little funky dip in it, and you'll notice this little dip right here. Okay, that little dip actually is called the supercooling. And when water starts to get down below, say 32 degrees or 0 degrees Celsius, 32 Fahrenheit, what it does is before it starts to freeze, it actually gets below that temperature. And as soon as one crystal starts to form, there actually is a heat of a release of energy, and that's called the heat of fusion. And all these little crystals start to form all of a sudden, and you get this plateau actually at the freezing point of the liquid. And so you get a nice plateau at 0 degrees Celsius. Now, moving into a phase diagram, as we start to look at the phase diagram, again, this is solids, liquids, and gases, but if you'll notice on the side, we're dealing with the relationship of pressure and temperature. So as the temperature increases of a system, so as we move this direction, you'll notice that we're going to go through different phases. If we start out as a solid, it's going to move into a liquid, and it's going to move into a gas. Up here on the on the chart here, I'm not even sure what this particular substance was, but as we move across, it says at 73 degrees, 73 atmospheres, we have this point right here. And as we move across that, that would be or not vaporization. That's actually heat of fusion. And so moving over that line is that heat of fusion. Moving back from that would be actually freezing. So when we get over to here, we have a line going that direction. That's vaporization. Moving in this direction would be condensation. And then down in this area, moving that direction would be to sublimation. And then moving in this direction, it would be deposition. Now there's some interesting points along this. Right here is a point which is called the triple point. And that triple point is when all three substances exist simultaneously. In other words, a solid, a liquid, and gas all exist at the exact same time. Now, there's a very specific pressure and temperature where that can happen. And so at that pressure and at that temperature, we get a point of which is called the triple point, and we see these substances exist. So this line along here is the is going from solid to a liquid, and that's either melting or freezing. Along here, this line here would be going from vaporization and condensation, and this bottom section is actually going from sublimation and deposition. If we look at water, what happens in the case of water is we have the ice, the water, and the vapor or the water vapor. You'll notice here we have this triple point is at 0.000 or 0.006 atmospheres, and it's actually just a little bit below the normal freezing point. It's 0.01. If we move up, you'll notice the freezing point's right here. At 1 atmosphere, we have a freezing point of 0 degrees Celsius. So actually, in the ice form, if we pressurize this, we're actually kind of crunching down the ice, and so we're actually condensing it. And so as we move up in pressure, we actually get more dense ice. Okay, and as we move across here, again, we're moving into a water form, and then we have this supercritical point. And supercritical means the water, the liquid, and the vapor actually kind of act like it's called a supercritical fluid. It kind of acts like the liquid, and it kind of acts like the solid or the gas, and that's what the supercritical point is. So this is enough of states of matter, and next we'll move into looking at why these states exist and some of the things that hold them all together.